Hi, welcome to the video tutorial for the 17th Let's Think Secondary Science lesson, Will It Float? I'm going to do this in two parts because I'm going to show you the demonstration due at the beginning and then talk you through the lesson just for ease of shooting it. The lesson focuses on the compound variable density, and it begins with a demonstration where you carry out two demo experiments to look at whether jars will float or sink. So the first experiment you carry out involves a minimum of 4. You could have 5 jars, depends how your technician sets it up. And you just carry out the demonstration with the students, and they see that this is a fair test because the volume is the same. The only thing that's different is the mass. And one by one you weigh the jars and put them in, and they come to the conclusion that the heavier the jar, the more it sinks. So it's quite a simple experiment that each of these jars is getting progressively heavier, and in the end the conclusion is the heavier the jar, the more it sinks. Okay, so that's one of the experiments. The next experiment is to do with altering the other variables. So you've got differing volume and same mass. And the conclusion from this one is the smaller the jar, the more it sinks. So you've got two conclusions. You've got the heavier the jar, the heavier it gets, the more it sinks. The smaller it gets, the more it sinks. So you can display the results in whatever way you feel, and then you introduce the students to a mystery jar. And the mystery jar is the same volume as this one that floats, and the same mass as this one that floats. So I'll just arrange them in order on the table again. So you can see here that the further you go down, they sink, and as you go across, and I would hide the sand in so the students can't see because they're just focusing on the two variables that we're altering here, the volume and the mass. So this jar floats and this jar floats. This jar is the same size as a floater and the same mass as a floater, and the students have to say if it will float or sink. And because those two float, they'll predict that this jar will float, and when you put it in, when they've chosen, it sinks. And the lesson really is about them exploring how mass and volume work together to give you the compound variable density, and we need to know that before we can decide if anything floats or sinks. Really what we're after in lesson 17 is the children to start thinking about how variables interact together, how density is the product of the size of something and how heavy it is. I think it's important to give your students time to talk through that. So if you think back to Does It Work?, the treatment and effects lesson, the children will have found that really quite difficult to articulate the fact that there's 4 things they need to consider before they can decide if anything works. And it's the same here. They need to think about things in a different way. They're imagining how two variables interact together. So the lesson starts with just a stimulus, a piece of chalk being thrown in the swimming pool and a huge log being thrown in. Which will sink, which will float, why? So it's just an easy stimulus for children to start talking, which you can actually do at the end of a lesson once they've got the appropriate language to help them articulate what's going on in this lesson. We start the students considering about a piece of chalk and a log, and then we do 2 simple experiments where we get them to think that there's something more going on when they have to predict if the mystery jar will float or sink. And the fact that it's got the same mass and the same volume as 2 other jars that float, it should float. But actually, densities in the context of buoyancy is a bit more complicated than that. They need to manipulate both mass and volume before they can say if something floats or sinks. So the aim of this lesson is to give the students the chance to start to think, what's going on? What is the relationship? We're going to go into much more detail with this in lesson 19. Floating and thinking, but at the moment we want them to start considering how mass and volume interact together. So it's really important that after they've done this and they've seen the mystery jar, they talk it through and they start to articulate what is going on in their own wonderful ways, because the bulk of this lesson involves the students playing quite a simple card game, and the instruction sheet is quite self-explanatory. There's the usual talking points in the bottom in the bold, but what they do is they have a series of cards which are similar to the jars in that as you go down they get smaller, as you go across they get heavier, but what we've put on the back is the answer if they float or sink. So what the students have to do is look at the card, think about how big it is and decide if it floats or sinks, and then turn it over. And what you'll get if you have a look is you'll see that when they arrange them all together, they'll see that there's a pattern where ones further down that are smaller and heavier over here sink, and the ones up here will float. And so the students start to think about how big it is, how heavy it is, and they start to get an embryonic sense of density. And that will then consolidate that further. But at the moment, it's more important that they actually are challenged. Something is going on. This should float, but it doesn't. They play the card game and they can see the pattern. Whether they play it completely or not isn't as important as the fact that they see the pattern and start to think, these ones up here float, these ones down here sink, these are heavy, what's going on? Regardless of how far the students have got through the card game and how well they're able to articulate what's going on here, I think it's important to give them this sheet to have a look at and to talk about, because they've already been primed. If you think about the questions to do with the card game, is getting them to think about what was surprising about the jar. When you look at a jar, what do you need to think about before you know if it'll float or sink? So it's not just how heavy it is or how big it is, it's a combination of both of them. And getting them to consider how the variables interact. And actually we've got a new type of variable here, which we call a compound variable. But I think it's important in the discussion, before we move on to the work card, we're going to answer this question. If you know how heavy a jar is and you know its volume, how can we work out if it will float or sink? And so the work card leads them through this to get the sense that if a jar weighs 800 grams but its volume is 900, it floats. So it's almost as if the volume is bigger than the weight, it will float. If the volume is less than the weight, it will float. Getting the children to think about what's going on here. And if you think about it, the first one, number one, cements that. Its volume is 1,000, its mass is 1,000, it'll float. And the children can tick if they're sure or not sure. And the idea is, by looking at the numbers in the table, they start to get a sense that there's some new variable here where we need to combine the mass and the volume. And if its mass and volume is 1 or less than 1, it will float, but if it's greater than 1, it will sink. So if you look at number 5, for number 5, it'll sink because the mass is greater than the volume. All we want the students to start to articulate. How they do it will be wonderful to see. And I think it's all up to the last part of the lesson when you generalise and review and reflect upon it, where it's the language and the imagery they use to try and articulate what is going on here. And if you don't get onto the second work card, it isn't important. What I think is important is to go back to this and think, this is really small and it sinks. This is really big and it floats. Why? This is heavy. This is light. What is going on here? To get them to think about it's heavy for its size, no matter how small it is. And that is it's really worthwhile giving them plenty of time to talk about that. The final work card introduces them to a new compound variable, the idea of momentum, where you've got to take in the speed and the mass of something before you know its total effect upon you. So that is quite interesting. And I just think it's up to you to decide how you want to use it. And it's probably worth talking that through with your with your colleagues, answer the questions yourselves and decide how do you want to do it with the students. You know, I think what's more important is to try and get them to articulate the concept as best they can, the idea of density, which we're going to follow up in the final Let's Think Through Secondary Science lesson.